Hey guys, my name's Cam,
And I'm Mohaj.
and we're going to be teaching you how to do a basic mass spectrometry question for Physics 2. Okay, so I'm just going to read off the question word for word as it is real quick. So basically, two isotopes of carbon, carbon-12 and carbon-13, have masses of 19.93 times 10 to the negative 27 kilograms and 21.59 times 10 to the 27 kilograms, respectively. These two isotopes are singly ionized, E+, which means it's a proton that we're working with, and each is given a speed of 6.25 times 10 to the 5th meters per second. The ions then enter the bending region of a mass spectrometer spectrometer where the magnetic field is 0.9 Tesla. Determine the spatial separation between the two isotopes after they have traveled through a half-circle pathway. Okay, so now let's write down what we're given and break down all the components and variables of this problem. Alright, so based off that passage, we were given a lot of information. So in that passage, we were told carbon-12 and carbon-13 have two different masses. Carbon-12 has a mass of 19.93 times 10 to the negative 27th kilograms, and carbon-12, and carbon-13 has a mass of 21.59 times 10 to the negative 27th kilograms. We were also told that they share a few common variables as well, such as both of them have a velocity or speed of 6.25 times 10 to the 5th meters per second. We also know that both of them have a magnetic field strength of 0.9 Tesla, and that they both have a charge of 1.6 times 10 to the negative 19th coulombs, because again they're both protons, which is denoted by that positive E in that question. So based off all this information, we know that the only equation that's going to work for us is R equals mv over qb.
Yeah. And now we have enough information to draw a diagram of how this will look. So over here we have two arrows of how these particles are going to be traveling in this magnetic field. By looking at the equation, we can see that radius and mass are directly proportional. So the greater the mass is, the bigger the radius will be. So hence we can determine that carbon-13 will travel further than carbon-12. And we are going to be solving for the separation between their two diameters, because we know that we have to calculate for a half circle.
Alright guys, so now what we've done is we erased all that stuff, all the known variables, and we started plugging it into our equation. So we did this equation twice. We did it once for carbon-12 and we did it once for carbon-13. So let's just go over the carbon-12 part first now. So again, the equation was radius equals mass times velocity over charge times magnetic field. So plugging in our known variables, we know the mass for carbon-12 was 19.93 times 10 to the negative 27th kilograms. We also know that it has the same velocity as carbon-13, which is 6.25 times 10 to the 5th meters per second. We also know that both of them have the same charge, which is 1.6 times 10 to the negative 19th. That's just the standard charge for a proton. And we know, given to us from our problem, that the magnetic field strength is 0.9 Tesla, which is the same for both of them again. So this is a very simple plug and chug. Just enter this into your calculator as is, and your calculator will spit out a radius value of 0.086 meters. So now let's go over carbon-13. Same deal. We're using the formula radius equals mass times velocity over charge times magnetic field. We're just going to plug and chug all our known variables. The mass is 21.59 times 10 to the negative 27th kilograms. Velocity is the same as this guy, 6.25 times 10 to the 5th meters per second. Charge is the same, 1.6 times 10 to the negative 19th coulombs. And magnetic field strength, again, is the same, 0.9 Tesla. So again, simple plug and chug. We're just going to enter this into our calculator as is and hit enter, and your calculator should give you a value of the radius being 0.0937 meters.
Yeah, but these are not the values that we're actually looking for. So looking at our diagram, we can see that we're not actually looking for the radius, we're looking for the diameters. So we need the diameter for carbon-12 and we need the diameter for carbon-13 to find the spatial separation between the two fight paths. So what we can do is that we can take the radius for carbon-12 and multiply it by 2 to find the diameter, which is equal to 0.172 meters. We can do the same for carbon-13, multiply 0.0937 times 2 to get our diameter for carbon-13, which is 0.187 meters. Alright, so now that we have solved for the diameters, we need to solve for the separation between the two diameters. So what we do is that we take the larger diameter, which is diameter for carbon-13, minus the smaller diameter, which is the diameter for carbon-12. And so the separation is 0.187 meters minus 0.172 meters, and we get a spatial separation of 0.015 meters. And that will be the separation between the flight paths of diameter of carbon-13 and the diameter for carbon-12.
Hope this helped you guys. See ya.